first discuss the problem, what's difficult about processing DITA. Then we're going to describe how this is solved using the pipeline, the DITA pipeline. And then we'll talk about in detail, or in some detail, the pre-processing of DITA when that's done by the OT, and then specifically we'll talk about two of the many different types of output. We'll talk about HTML output and PDF output. There are, of course, other types of output. There's, Word output and so on and so forth. We're not going to really have a chance to talk about that. So I'll jump right into it unless anyone has any questions. Okay, great. So here I have what's basically a very simple DITA topic. It's probably similar to the sort of DITA topics that you have given to your toolkit on input. It's just basically it has the XML declaration, a doc type. It's a simple topic. It has a title, a body with a couple of paragraphs. So just to start looking, even this simple case, we're going to have a whole bunch of different things that we need to process before we can produce any kind of output. In my example here, each of these paragraphs has something in it that requires a different kind of processing. The first paragraph here has a conref. That means that sometime while we're processing our DITA, we actually have to import text from some other file and bring it into this file, because we don't really have a conref mechanism in, say, PDF. So in order to be able to produce output, we're going to have to somehow or another take care of this DITA feature and resolve the conref, replace it with the actual text. In our second paragraph, we have a cross-reference. So a cross-reference has some text to it. Well, DITA OT does not require that you actually give some text describing, please see a particular table. It doesn't say table 5. It doesn't require that you write table 5. It'll figure out for itself, and it'll put some text in there, and it'll make a link as well. So in the second paragraph, we also have to retrieve information from another topic. Instead of bringing it straight in, we're going to figure out some text to put in, and we're going to put that text right there where the cross-reference tag is. And in the third example, we're using a conditional attribute, and that particular attribute might require, during pre-processing, that we simply remove the whole tag. We need to do all these kinds of processing in order to produce output that we're familiar with HTML or any type of output that doesn't have these features built in. So in the previous slide, we saw that some of the items that need pre-processing are conrefs require some pre-processing, cross-references require some pre-processing, conditional text requires some pre-processing, and all of these need some modification from their original form in our final output. But there are more things that require pre-processing. In fact, there are a lot more things that require pre-processing. Nav title may require pre-processing. If nav title, if you have a map that has a nav title on a particular topic and you use the lock title attribute, that means that you're going to be changing the title from the map. So that will require processing to change the title in your topic. Keyrefs require processing much like conrefs. Sometimes you can put metadata into the map, into the topic ref, and that metadata will have to get moved into your topic. If you have relationship tables, so those relationship tables need the information that starts off in the map needs to make its way into every topic so that you can output, your related links at the end of your topic. And similarly, there are some things that are just generated. the relationship between a parent and a child is simply generated, you don't actually have to specify that there is a parent and child relationship. Once you've already set it up in your map that one topic is a child of another topic, those related links are going to be generated automatically. Chunking, copy to, Conref is another DITA 1.2 feature. There are more things that need reprocessing. So there's a lot of different DITA features, things that DITA provides that aren't necessarily going to be available in our output, and we're going to somehow have to produce output that has all of these things already processed, already resolved, already replaced or moved or rearranged into something closer to the output. So now that we've seen that we have a whole lot of different DITA features, and I think this is just a small subset, we have all these different things that the specification has. Now we need to build a DITA OT. How do we do that? We want to process DITA correctly, and we want to make sure that we deliver on all of the features that the specification has. So we want a solution that, first of all, does all of these things. We want to make sure that our solution makes it easy to reason about correctness, because after all, we want to be sure that when we do chunking that it really does chunking correctly. We want to be sure when we process conrefs that it processes conrefs correctly. And we also want to provide a way to make many of these DITA features are things that are needed in all output types. So if you're going to process HTML or you're going to make PDFs, either way, you want to be able to be sure that you're using the same processing that is well tested to take care of everything like conrefs and keyrefs and cross-references and all of the other things that we had just listed. So our basic solution is we're going to make the DITA OT as a pipeline. What this means is we're going to take each feature and we're going to make it one step. We're going to process conrefs, and that's going to be one step that we can reason about and we can look at independently of any other step. So in order to construct this as a pipeline, what we're going to do is we're going to set it up so that we have our input is DITA and our output is DITA. So then when we have input that's valid DITA and output that's valid DITA, that allows us to chain a whole bunch of different changes together. So we're going to have conrefs we can process in one step, and cross-references we can process in another step, and related links we can process in another step. And we can be, since we're making each step be something self-contained and separate, we're going to be able to chain them together but reason about the correctness of each step locally. So our goal is to have a pipeline, which is our chain of steps from one to the next, that allows us to make sure that we deliver on all of these DITA OT features. And not only do we want to deliver on all of the features, but we'll be able to add these features. We can add or remove features in theory by just adding another one of these links in our chain. So that's the DITA OT pipeline. That's the source of this jargon. It's like a pipe. We put the DITA in one end, we pass it to one step, then to the next step, then to the next step, and each step makes some small change. And eventually, when we come at the end of the pipeline, that's when we produce our output. So, of course, this doesn't necessarily solve all of our problems. We still need to evaluate each step to make sure it's correct. The other key point is that we need to ensure that the order that we do things is correct. So in theory, some of these features are not related to each other. So if we move the order around, so then there's no harm done. But some of these things are in fact related to each other, and then we have to be careful to make sure that our pipeline is built in the right order. So I'll give an example of one step in the pipeline. This is an example of the particular paragraph in that sample DITA topic that we were looking at before. So before the Conref step, we can see that a whole bunch of changes have already been made. We see that previous steps have put in the class attribute. We see that previous step has put in this xtrf attribute, which tells you where this element came from, which file this originated in. And we have this xtrc element, which tells us which element there this originated in. And so we see, I'm giving an example from something that's in the middle of processing. Some previous steps have already taken place. There are a number of steps to go. And just looking at the Conref step itself, the transformation looks like this. The first, the input is valid DITA. It's a paragraph. Usually you don't see the class attributes when you're editing, but they're there. They're part of the DTD. These other attributes that have been added are debugging attributes. So we have some pre-processing done. We've got these attributes added already, but the Conref hasn't been resolved. And then when we run our Conref processing, so that same paragraph is replaced with the element the way we would expect it to be. And now it still has the debugging attributes that we'd expect. Now we can see that the xtrf attribute has changed. It's not because this step is rewriting all different kinds of attributes that we have. It's that all the Conref step is doing is exactly what the Conref feature does. The Conref feature says we're going to replace one element with another element. So here we replace the paragraph that we started with the paragraph that it was pointing to. And that paragraph that we took from the other file already had an xtrf attribute from its pre-processing. So we've kept the information from that element, and now it appears in this element. And for debugging purposes, this is very handy because now we could see where this came from. So that's why xtrf and xtrc are useful as debugging attributes, just to figure out what's going on if you happen to be looking at partially processed files. These files appear in your temp directory. So this is just an example of one step in the pipeline. We're making one simple kind of change, and we can reason about the correctness of that step in the pipeline. And it's going to move around other things that have already been taken care of. In this particular example, just these couple of attributes are going to be moved around by the Conref step, but that's because some of the processing has happened, some of it's yet to happen. I just have a footnote here, except that it appears in bold for whatever reason, that if you happen to try this at home, then you're going to discover that there are other differences between the files before and after because of some details in how the XML engine is working. But those differences have no meaning in XML, like an empty element which is self-closing versus an empty element which has no content. From the perspective of an XML processor, those are exactly the same thing. So the files might look different, but the only change that's really going to happen is you're really going to have the Conrefs moved. Okay, so that's the basic outline of what the pipeline is and how the DITA, the model around which the DITA is constructed. I think there's a good time to pause for questions if there are any. Nobody? Okay. All right, so now we understand that we have a basic model. We have this pipeline. We're going to take DITA. We're going to put it through a bunch of steps. We're going to try to make sure that they remain valid DITA. And Now we're going to talk about how you actually see that when you're running the DITA-OT. I'm just going to have some quick notes about the log itself. So when you run the DITA-OT, you see a whole bunch of stuff that scrolls by on your screen. So just we're going to talk, instead of talking specifically about the pipeline, we're just going to take a brief diversion to talk about what that log is. DITA-OT is a mixture of mostly of three different things. It's three different languages. Ant, which is usually a build tool, popular for Java. It's used often for building applications from Java source. There are other uses of it, but so Ant is one piece of the puzzle. Another piece of the puzzle is Java. There's some parts of the DITA-OT are written in Java, and the third is XSLT, meaning XSL style sheets. XSLT is the style sheets are technically this is the XSL transformation language. These three languages together make up the moving parts of the DITA-OT. So just to understand what's going on, people have two different ways that they run the DITA-OT. Some people run it by starting Ant, some people run it by starting Java. In both cases, the same thing happens. Ant is the system that drives the whole process of running the DITA-OT. It's not used quite in the way that it's familiar to Java users. It doesn't manage dependencies. Basically, if you change nothing in your input and you run the DITA-OT again, it's still going to run the whole way through. If you would do that in Java, it would behave differently. But Ant is basically the tool that drives the whole sequence. If you look in, there's a series of files mostly called something like build DITA2 xhtml.xml or build init, build general in the main DITA-OT directory. Those are Ant files. And those Ant files are the conductors that run the whole system. It's not a very sophisticated language, or it's not a regular programming language. It's basically XML, and it provides markup about the steps that are supposed to happen. So if you start your DITA-OT with Java, you're just starting Ant with a wrapper around it. It sets up some logging, and it provides a better way to enter some parameters, and it runs integrator. But basically, either way, you're running Ant. So if you run it via Java, you have messages that look like the top half of this slide. If you run via Ant, you have messages that look like the bottom half of this slide. They're basically the same messages. So the reason that I'm going on to all of this is that these messages, you're seeing the different steps in the pipeline. If you see here, there's debug and filter input files. So debugging means adding those debugging attributes that we saw before. It's adding things like xtrc and so on. The filtering is removing conditionals, the text that is supposed to be dropped. So here, in both cases, you're seeing step by step what the DITA-OT is up to in each step. So both logs are showing the exact same information. If you notice, Ant has a couple more steps than Java does, but that's basically because the Java wrapper is just hiding those extra steps. So this log is our insight into what's going on, where the DITA-OT is in the process, and we can see through these steps, what the DITA-OT is actually doing. If anybody is upgraded, I assume many of us are running the newer versions of the DITA-OT. DITA-OT 1.5 supports DITA 1.2. The DITA-OT 1.5 has a bunch of extra steps for things like resolving Conref push. So the reason there's more steps in the log and the log is longer is because it has more steps in the pipeline. It's doing more things. So this is basically what I had just said, that the Java version is easier to read just simply because it's using the description in the AND file as opposed to the name of each step. But we're looking at the same thing. The key point that I'd like to make 2 points about how the pipeline appears here. One is that there are other things that happen other than processing the DITA files themselves. Like if you have images, your images get copied. So that's not part of processing the DITA into output, but it is part of the general processing. But this pipeline, this set of steps that happens to your DITA files, that pipeline isn't ever mentioned somewhere separately. It's just a set of steps that you see as part of the log. So even though we're discussing just the pipeline and we're not talking about copying your CSS files or your images or anything along those lines, when you actually look at your logs, you'll see things mixed together. You'll see some things that are part of the processing the DITA files themselves and part of the other things that are just part of getting the job done. So there's no separate implementation. It's just part of the same system. If you look inside those AND files, the AND files themselves don't make any clear distinction. But there's one thing that's very confusing, that there are things inside the AND files, if you look, that are called pipeline. Those things run part of the pipeline, but not all of the pipeline. So if you take my encouragement to go and look inside the AND files themselves, you'll notice that it does say pipeline, but basically only on the steps that are implemented in Java. And then a footnote on the footnote. Basically, some steps are implemented. So ANT is coordinating the main processing. Some of the actual steps are written as style sheets, as XSLT style sheets. Some of them are written as Java. There's no rhyme or reason to which is which. So those steps that are implemented as Java usually have a pipeline guide. That's basically the footnote about the logs. So practically, one of the takeaways that you should have from this webinar is that when you're looking at the logs, you're seeing a series of steps. One step feeds into the next. And some of the stuff is not necessarily going to be a direct feed-in from a previous step. Some of the things are additional things, but the OT doesn't distinguish between them. I think that it's also good to reflect that once we've gotten to this point, we can understand why the DITA sometimes behaves the way it does. I think if anybody has spent a long time looking at these logs when they're trying to figure out why their DITA didn't successfully give the output they were expecting, you may find that there's a whole series of errors in your logs. You start with errors at the beginning and it keeps going and going, there are more and more errors. So, I'm sorry? Is there a question? I can't hear. So, if there's a question and there's a sound problem, then please just type it in the chat window. Thanks. So one of the things to note then is that because this is built as a pipeline, one step feeds into the next, so sometimes you have cascading errors. If you have an error in one step, the DITA doesn't necessarily give up, because if you have 100 files, it could be that 99 of them are fine. So the DITA will try to keep processing. But that means that if you have an error in one file that failed, so that input, that failure is now input into the next step, and you'll get a failure again. and that in turn is a input into the next step. And so you'll get a cascading chain of failures. That's why if you're trying to figure out what went wrong by staring at DITA logs, it makes sense to start from the beginning. The first error is probably real, and then after that you may see cascading errors that really don't mean anything. Like, for instance, if you have an early error that prevents one file from being produced as output, so that file, if it's, let's say, referenced as by Conrefs from another 10 files, so those 10 files will fail to open that file to get the information they want for the Conref, because once it failed, the file doesn't exist in the temporary directory anymore. Once it doesn't exist, that means all the subsequent steps that depend on it will also fail. So if you see 30 errors in your DITA log, it might really be 1 error or 2 errors, and those errors all just cascade through the pipeline. Okay. So once we're talking now about the steps of the pipeline itself, we're going to talk about the specific construction. We'll talk about why the order is the way it is. So the first thing you should know is that I am not giving you complete information. The best current source of information is from Robert Anderson, who's the architect of the DITA itself. And at the link over here on dita.xml.org, he has information about many of the steps and explains what each of them do with a paragraph or so. And I believe that is still being updated from time to time. So to explain in detail why the pipeline is set up the way it is and what each step is doing, you should go there. So that being said, I just wanted to explain that some of the logic behind it, the basic category of logic, that some of the steps, it doesn't matter what order they go in, but some of the steps must come before other steps. For instance, one step we process cross-references, and another step we process nav title and lock title. So if you think about those two features, how they interact, just before you even get to the DITA, when you create a cross-reference from one topic to another topic, you want to make sure that the cross-reference says in it the title that the reference topic actually has. So if you're going to change it using one feature, nav title and lock title, you want to make sure your cross-reference actually points to the new corrected title. So we have two features that interact. One changes the title, one references the title. In that case, you want to be sure that you take care of changing it before you get the text for the reference. So in cases like that, you're forced to make the text, the nav title and lock title processing take place before the cross-reference processing. So some of the steps are necessarily in one order or another because the features of the DITA specification itself imply that one thing has to be taken care of before the other. So that's one issue about getting the order together in the pipeline. And then some of the other steps should come before the others, like you want to process conditional attributes early. If you're going to remove some text, you don't want to spend any other time doing any other processing on that text that you're just going to throw away. So we have some steps that have to come before others, some steps should come before others, and part of the challenge in constructing the pipeline and trying to make sure the order is correct is to make sure that all of the features behave the way everyone expects them to behave. Okay. So we're going to give a little bit more explanation about the steps of the pipeline, and then we'll move on to the overview about what actually happens during each part of the processing. So I had mentioned before, each step during the pre-processing outputs valid DITA. so that you can have a minimum amount of interdependence between each successive step. So if for some reason you skip a step, the output from the previous step could go straight into the following step, and the missing step won't cause any harm. It just won't provide the feature that it provides. The DITA actually does use this. For instance, if it knows that there are no Conrefs, it'll skip the Conref step. So having this rule that every step takes DITA and outputs DITA allows you to chain them together in whatever order is appropriate and to skip steps as need be. It also helps you catch errors, just because each time you're reprocessing those files, you're going to validate the file and be sure that it's valid DITA at each step, and that validation helps you ensure that nothing strange happened to the file. DITA specification has certain features to help this happen. There are these debugging attributes that we've discussed before. There's a related links section in each topic. Even though it's better advice to use rel tables in your maps, there's a related links section in each topic that allows the preprocessing to move the related links into each topic in the relevant spot, so that each topic can actually hold a list of related links that are constructed from rel tables and from the structure of the map itself and whatever else creates related links. The spec allows us to put all that information into the topic. Similarly, it has space for metadata that you might actually write in the map. You can stick all that information into the topic. The spec has a way of allowing all these preprocessing steps to put information into the DITA topics so that the DITA topics are closer to your end result. So our basic goal with all of this preprocessing, we want to make sure after we do all of our preprocessing that all the DITA features are processed into as simple XML, as simple DITA as we can get, and that each DITA file should stand alone, so that each DITA file, by the time we're done processing, has all the information it needs for output. Same thing with the map. The map is going to be merged. If you have a bunch of submaps, it'll form a single map. And that map will also stand alone. We'll have whatever information it needs. It'll gather titles from the topics. So you're going to have each file in this temporary directory. When the preprocessing is done, each one is basically going to be standalone. It'll still be valid, but it'll have all the information, and all the preprocessing will be done. All the features will have been taken care of, so that the final output doesn't have to worry about all of the DITA features like cross-references and conrefs and so on and so forth. Okay, so our basic goal of preprocessing is to get to this endpoint where we have simple XML that we can convert into simple XML that we can convert into our output without worrying about all the features that DITA provides. So preprocessing tries to worry about all these features, and then our last final output step tries to worry about just making sure that we take care of the output itself, the format that we want to produce. The HTML processing is only going to worry about things that are specific to HTML. PDF is only going to worry about things specific to PDF, and so forth. So we'll spend one thought just talking about the performance issues that having and that the OT built this way poses. So given that we've set it up so that we're going to have each step does only one thing and does that one thing well, in theory, that means that the pipeline is going to read and process every file for every step. So if you have, I don't know the exact numbers, but if supposing you have 200 topics and you have 20 steps in the pipeline, so then you're going to have to read the files 4,000 times. That's a lot of repeated reading of files. So there are a bunch of different kinds of files that you're going to keep reading over and over again. You're going to read the DTDs over and over and over again. You're going to read the style sheets. Style sheets are different. Style sheets, if you're, let's say for example with Conrefs, we keep discussing Conrefs, so there's a style sheet that actually processes the Conrefs. So that style sheet, if you have 200 topics that have Conrefs, it's going to have to be read 200 times. And the DITA files themselves, you're going to have to read them and write them and read them and write them and read them and write them. So this is clearly slow. This is why the DITA OT takes a long time to run. Even if you're running books that are of medium size, if you're creating a couple hundred topics, the DITA OT can take significant amounts of time. Part of this is just simply because it's doing repeated processing over and over again. In practice, it's not as bad as that. So for anyone who is still running the older DITA OTs, the latest versions of the DITA OT, I think it's starting from DITA OT 1.5.1, but I'm not 100% sure which version was the first one. If anybody does care, please contact me afterwards and ask me to find out which version this is true. But Elliot Kimber provided a patch that caches the DTDs. So instead of reading the DTDs, if you have 20 steps and 200 files, instead of reading them 400 times, it reads each DTD once, and it saves them for later. So that can shave a significant amount of time off of processing large sets of files. So thanks to Elliot Kimber for that. And that also means that anybody who's running DITA OT 1.4 point something has a good reason to upgrade. So that mitigates the DTD problem. For the style sheets that have to be read over and over again, Ant has a built-in method to cache those. It reads the style sheet once, processes it, and it saves that processing. So in theory, style sheets only have to be read once. There is a price to pay, though. As implemented right now, it costs a fair amount of memory for that to happen. And that means, in theory, that when you're running the pre-processing, you can run out of memory if you have enough topics large enough or whatever the particular circumstances are to create a large data set. Having these cached style sheets might make you run out of memory, but it does make things run faster. Sometimes a good tip for those people who ever run into this problem, you can shut off this cache. You can force it to reload the style sheet each time. It'll run slower because each time the style sheet is used, it's going to have to be read again, but at least you won't run out of memory. And then there's no cache for the DITA files themselves. If your DITA input file has to go through a whole bunch of steps, it gets read and parsed and written and read and written and read and written. So there have been some discussions about actually implementing the pipeline as a pipeline, where one step feeds straight into the next without saving the files to disk between each step, but it doesn't exist yet. So we pay a price for this easier implementation. We have this pipeline. It's easier to reason about correctness. It's easier to make sure that pieces don't step on each other's toes. But part of the price of not building it as one unit is that things can be slow. So that covers the entire pipeline as a whole. That, I think we also discussed pre-processing. We discussed many of the steps. We didn't discuss in specific detail what each of those steps are. We certainly don't have time for that. There are many of them. And that link that I provided before is very useful for this. The slides should be available after the webinar. anyone who is registered, I believe, should be receiving a link to the slides if you're interested. So if you need a particular link to that particular website where all of those things are listed, so you should be getting that via the slides, and if not, feel free to email us. So that's the pipeline, that's the pre-processing. Now we're going to discuss two output types. We're going to discuss HTML, and we're going to discuss PDF. HTML is really actually a broad category of outputs. There's HTML, just plain HTML. There's HTML in the form of chums, in the form of Windows help, in the form of Eclipse help, and so on and so forth. So HTML actually is used in many things. The way it's actually constructed in the toolkit, it's a building block, but we're just going to discuss generating HTML itself. So in theory, the HTML step itself is very simple. It takes our DITA, is still a DITA that came out of the pre-processing. And we've taken care of all of the DITA features and we've simplified them away. And now we basically just have an XML file with all the information we need to generate the HTML. So the style sheets do have to do some work. They have to change between structures that aren't quite similar. The markup for DITA tables and HTML tables aren't quite the same. But conceptually, each transformation now is pretty simple. We can take a UI control and we can replace it with another tag, with a span, with a class equals UI control. And in fact, this step doesn't really do much of anything about formatting. The DITOT's HTML output assumes that formatting is going to be controlled by CSS. So it doesn't do anything, it doesn't insert formatting information. It's basically doing a translation. We now have a DITA file that's similar to HTML, but it's a totally different dialect. It's DITA, not HTML. So we translate more or less one element to the next. There are things that are a little bit more complicated. If you look inside those style sheets, there's all kinds of complicated markup. Basically, those are for things like DITAVal files, if you're going to use DITAVals for flagging, so you need to highlight particular pieces of text or insert images. If you're going to use any of those features, so the style sheets here will add additional HTML elements to provide those features. But in the normal case, where you're just producing output, it's a fairly straightforward translation from, let's say, UI control to, let's say, span. So in terms of the pipeline, HTML is basically just the last piece of the chain. When you take your DITA input file that goes through this whole chain, the last piece of the chain is not going to produce DITA again. It's finally just going to produce HTML, and then you have your output. So the pipeline feeds into HTML, and then we're done. So conceptually, once we're looking at the DITA in this overview form, we are HTML is fairly easy to understand just simply because there aren't very many steps that are HTML specific. The pre-processing had also created a merged map. It had taken all the submaps that had been linked and formed a single map. That single map is processed again pretty similarly to produce a table of contents file, because if you're producing straight HTML output, there's also an index file. It's called an index file, but it's basically a table of contents. That table of contents file is basically, again, a straight translation from the map itself. Any questions? Okay, so we'll move on to PDF. PDF processing is more complicated. It has more steps than HTML. So we'll discuss the steps that PDF takes after we've done all of this pre-processing. We still have several more steps to produce PDF. We're going to talk specifically about how the FO plugin actually does this. The trans type that is now called legacy PDF, the original PDF implementation in the toolkit, was more similar to the HTML transformation. But in both cases, we're going to have one more step, at least, than we had in the HTML, because PDF is a complicated format. And the DITA was not ambitious enough to also take on creating a tool to generate PDFs. There are many nice tools for generating PDFs available. So what we want is we want to build something that translates DITA into an intermediate format and use existing tools that generate PDFs. So we're going to at least have two steps. We're going to have at least one step to generate an intermediate format from DITA and take that intermediate format and produce PDF. So we have at least two steps to start with. In theory, that intermediate format didn't have to be terribly complicated. In fact, writing the PDF output didn't have to be terribly complicated, since you can generate PDFs from HTML and CSS. There are tools available. In practice, it didn't pay. CSS used to be less sophisticated than it is now. It's getting progressively more and more sophisticated. More and more features are added to it over time. And people have very specific demands from their PDFs. People care a lot about how their PDFs look usually. They care very specifically about page size and layout and margins, perhaps more so than they do for HTML. So we have also some specific demands that people want from their PDFs. People want to have an index. And I can't say that I'm completely up to date with the very latest of CSS standards, but as of the last time I checked, there really wasn't any facility for producing indexes, in particular producing page number references in an index in a print output based on CSS. So the upshot of all of this is that we were using a different language called XSLFO. XSLFO was defined together with XSLT. That's why they both have the name XSL. But it's a completely different and unrelated language. XSLFO is a language that has a lot in common with CSS, but it's basically designed for producing hard copy output like PDFs. So we're going to also discuss briefly just to explain the reason that I'm specifying these two particular demands that people have from the PDF: the index, the language-specific font control. People have very specific font requirements in PDFs often enough, and these are going to require additional steps in our processing. So when we're discussing PDF processing, we're going to take more than these minimal two steps. And the reason I'm highlighting these two features is that implementing these features has caused the PDF2, now known as the main PDF output, to have more steps. So let me just explain what I mean by language-specific font control. If you have, there are very few fonts that cover most languages. If you have a mixture of Chinese and English, so Chinese fonts will probably have some English characters in them, but English fonts usually won't have Chinese characters in them. if you want to mix languages, you really can't rely on any single font to cover all languages. There's Arial Unicode MS is probably the one font that has the best coverage for all different languages, and it doesn't necessarily look great, and it doesn't necessarily fit with people's branding or other kinds of reasons people choose specific fonts. So one of the things people want to be able to do is mix fonts. You may want to have a single publication. The Chinese characters come from your Chinese font, the English characters come from your English font, and this particular feature requires a certain amount of additional processing, and it's going to require more steps. So given that we're discussing the steps in our pipeline, the PDF pipeline is going to have to take care of allowing us to produce an index, and it's going to have to take care of allowing us to do our high-quality font control. We're not going to discuss the details about PDF style sheets. I understand that we've covered that in other webinars, but we're going to just spend some time discussing what steps does the PDF processing actually take when we are producing PDF, and within those steps, hopefully other webinars in this series have covered all of the important details. Okay, so the first step in the pipeline to produce a PDF is called topic merge. You may have seen it scrolling by in your log. Topic merge is a step that creates one big file out of everything. Takes the map, takes all of your topics, puts it into one big file. You're going to need it all in one big file because your output is going to be one big file. You're going to be producing a PDF that has everything in it. So topic merge is a step that collects all the different pieces and puts it into a single XML file for later processing. It's good to know about the existence of topic merge because it's just a good opportunity to do certain kinds of processing that you might want to do on a topic-by-topic basis. If you want to control the input to the rest of the PDF processing, this is a good place to do it. This is also the slide where we justify that part of the description of the webinar where we said we were going to discuss the good places to insert your own customizations into the Toolkit processing. So, truth of the matter is that most of the previous steps you won't want to modify. It's good to understand so that if things go wrong, you can figure out what happened. If there's a bug, you'll be able to track it down. But most of those things are simply implementing the specification. You're not so likely to want to, make Conrefs behave differently. But topic merge is actually a good opportunity for changing the behavior of PDF processing. One example is just that one of our clients wanted, instead of having the toolkit fail if the topic was missing and we were producing a PDF, they wanted us to just simply put in a title that says missing topic. So if you would do it in this topic merge stage and you would create a topic that just says missing topic as its title, so it'll go through the rest of the processing as if there was a topic that said missing topic in it, and it'll appear in your table of contents and it'll appear in the appropriate place in the document, and therefore this gives you a good opportunity if you want to make those kinds of changes that basically change the kind of DITA input that your PDF is going to see. It's an excellent opportunity to take care of that. If you're wondering about how to do this, if you look in the style sheet that implements this, it's called topicmerge.xsl. In the FL plugin, you can actually find an example. There's a very similar step because the way the PDF processing actually works it runs through all of the topics that exist in all of the files, and it ignores the map, more or less. So the existing topic merge style sheet actually takes every topic head and creates a fake topic that matches that topic head. So if you need this sort of behavior, you can actually look at the example that's already there. Okay, so topic merge is the first step. It makes everything into one big file. It's just a note. It's partially implemented in Java and partially implemented in XSL. If anyone needs more details, please ask. Okay, the next step is, so that generates a big file called something_merge.ditamap. That file is, that something is the name of your ditamap. So if your ditamap is called taskbook, so the file that will be produced at that step will be taskbook_merge.ditamap. Next step in the PDF processing, we take that merged ditamap and we convert it. I have a typo here. This should say to something called stage1.xml. That collects all of the index terms and just puts them at the end of the file, so that the next step will be able to create the index. This step is just simply collecting all the pieces to get ready to create the index. Very unlikely that you'd want to make any changes there, except for the fact that unfortunately the index processing is still somewhat buggy, so there's definitely room for improvement here, but it's not something you're likely to want to customize. So that is the second step in PDF processing. The third step is the meat of the conversion. This is where you take stage1.xml, which is more or less DITA. At this point, it is no longer quite standard DITA, because after the topic merge step, we started on the process of making the specific kind of input we need to produce PDF. We started collecting index terms, and there was no facility in DITA to give us a place to store all of these pieces of bookkeeping information that we need. So it's not exactly DITA anymore, it's pretty close. It looks like DITA plus a couple of odds and ends. That's stage1.xml. So our main processing now is going to take this DITA, or almost DITA, and we're going to produce XSLFO. XSLFO is basically a very, it's a language, I want to say simple, but it's not simple in the sense that there are many, many different options and many different ways to use the different options. But it is not powerful. It doesn't have facilities for numbering lists, for instance. XSLFO knows very little about the relationship between elements, doesn't do any calculations. XSLFO is basically a display language. It explains to the later processor that we're going to use how to lay things out. So this stage, we're going to produce XSLFO. We're going to take our data and convert it to XSLFO. This step is analogous to the HTML step we had discussed earlier. We're taking our data, making it into XSLFO, which from our perspective is, from the perspective of the developers who are trying to create PDFs, this is basically our conversion. We're going to use a third-party tool afterwards to make PDFs out of this XSLFO, but this is our opportunity to do all the customizations. This is the part that, if you've taken any of the other webinars about customizing your PDF output, this is the stage you're changing. So this step adds page sizes, fonts, all kinds of information that you're going to need to create your PDF. All of the layout information is going to be added at this step. The one thing that we don't take care of yet is we don't actually use real fonts. The way the PDF plugin is set up, we have these logical font names. We call them things like sans or monospace or front cover font or Aryeh's font. You can name these fonts whatever you want, we're going to use, at this step, we're only going to use logical font names, sort of just a piece of text that describes which font we're going to want in the end. So right now we've done most of our conversion. This step is the third step in the PDF-specific processing, just has left out the font processing. So now the fourth step takes stage2.fo, converts it to stage3.fo, and all it's doing is it's looking for characters in specific languages. They're based on this configuration files to decide which characters to look for, but in short, we're looking for characters in different languages, and it'll just put an extra tag that marks each one of these specific characters to say this belongs to a different language. Stage 3.fo to topic.fo is the final step to produce the final version of the FO file. Stage 3 to topic.fo is now going to substitute all of these font names we've been using for real font names. There's a file called fontmappings.xml, again a typo, I'm sorry about that. And that final step, we're going to say if you were using sans before, maybe now, if you want, if your font mappings file has defined it, we're going to replace it with Arial. The reason why we do this is because, let's say, in a section which is using Arial for English, you actually want to use some other font for Chinese. So this will take a look at these Chinese characters that have been marked, and it'll look up the Chinese font that is under sans, and it'll use some other font. So this logical font and physical font setup allows us to pick different fonts for different languages. So we have these two different steps take place after we've basically produced our FO. We're going to look for all of the text in each language. We're going to mark it. And then the final step is going to take each language and put markup to make sure that the correct fonts, the real fonts, are used for each language. So that's the last step of producing an FO. So the final step, of course, is to make a real PDF. You're going to take topic.fo and run it through something called an FO processor. Practically speaking, we support 3 FO processors in the Toolkit. Apache FOP is free, but it doesn't have the necessary support yet for producing indexes. But basically, other than that, it's fairly full-featured. And then the 2 commercial versions are RenderX's XEP and Antenna Formatter. These processors are basically going to take this standard FO file and actually generate a PDF for you. That's the part that we're going to send to this third-party tool, whichever one you choose, to do the last step in our pipeline to produce PDF. So PDF processing is in fact more complicated, at least as implemented now, than HTML, but hopefully you now have some insight into the pipeline, the HTML processing, the PDF processing, and the construction of the toolkit. And that's all that I have planned at this point. Are there any questions? Okay, well, thank you very much. Thanks for joining. If anyone wants a download, I understand that we'll be sending that out a recording of this presentation afterwards. And you're invited to listen in on, to join any of our subsequent webinars. Thank you all very much.